Hey everybody, David the AI Guide here. Welcome to another episode. Thanks so much for tuning in. Be sure to follow us also on Facebook, Instagram, Twitter, and LinkedIn. And click the link. Free resource. Learn more about AI. And it will guide you toward a beta program that we have opened up for the first 5 people to go through a new course that will help you pivot from what you're doing now to an AI-safe career. This is a main focus here at the AI Guide, obviously, is I care deeply about people 18 to 34, and I want to protect them from AI and help them find a successful career that won't be automated out of existence. The founding reason for the AI Guide. So I hope you take advantage of the resource and consider becoming part of the beta group, because after the beta, we will be charging for the program, but I think it's really going to help you find a career that truly will be AI safe and fits your personality and skills. So thanks, and also get my new book on Amazon, The Beginner's Guide to AI, quick history at first, and then how AI is already impacting 10 industries. It's a short read. You can probably read it in the whole book in 2 or 3 hours. But it's designed to give you the base knowledge you need to understand the complete revolution that's happening in the world today. So this video is on an article in Scientific American, linked below, but the article is about AI generates hypotheses human scientists have not thought of. And we've talked some about that. We talked about it in the context of folding proteins, which people can't even begin to figure out yet, but a neural net can predict how proteins fold. But this talks about most cars are going electric, right? I've done a bunch of stuff on that recently, but one of the gating factors is batteries, right? If all the major automakers are making, let's say, 10 million electric vehicles a year, that's 10 million battery packs consisting of hundreds of millions of individual battery cells. And lithium has been a gating factor, right? Lithium doesn't exist everywhere in our physical environment. There's certain places where it comes from. China's one of them, and the pandemic has exposed the problems with the supply chain that goes around the world. There's also lithium in South America, but a lot of scientists are trying to figure out what material can we use to replace lithium that's more commonly available. And so this story starts out talking about a neural net that was created by the University of Liverpool in England to streamline the creative process that scientists use. So when they start looking for new materials, and by the way, there's a complete revolution in advanced materials going on right now. I've mentioned this before, how some people believe there's multiple periodic tables behind our current periodic table. But the topic at hand, lithium, scientists typically would use a database to start to get candidates that might replace lithium in batteries, and then they would have to go through hundreds of candidates one by one, a very slow, tedious process. So the University of Liverpool created a neural net to screen to look for candidate materials and screen them. And with the neural net, they were able to come down to just four prospective materials that just might work. So that's a clear example of how an AI algorithm using deep learning was able to significantly accelerate the research research that they're doing at the University of Liverpool by months and months and months. This is why AI is itself an exponential technology and an enabling technology of other exponentials, and materials is one of them. Finding new materials in days or weeks, not 6 months or a year. So exponential. So they talk about what a great tool is, and then the next part of the article talks about a physicist at Zurich's Institute for Theoretical Physics in Switzerland, which created a neural net to help them start to make their way toward a unified theory of physics. We've talked about this before. There's a disconnect between traditional Newtonian physics and quantum mechanics, right? And they're looking for a unifying theory that will bridge the very different behavior of matter at the gross or macro level and the quantum level. And now this university or Institute of Research at Theoretical Physics in Zurich, Switzerland is using an algorithm to help them try to get closer to this unified theory, which in scientific terms would be virtually the biggest breakthrough in science and history. But that's probably a little ways off, even with AI. But one of the things they talk about in this article that we've talked about before that's really important is what they call the black box problem, meaning people who create these neural nets do not understand how they work. They don't understand how they get to the decision they get to. And that's a huge problem. It's a huge problem for transparency. It's a huge problem for trust. And it's a huge problem for them being able to use a neural net for specific uses where regulations are in place. Because if you can't explain how you got to a certain decision, the regulators aren't going to let you use it. So a lot of people in AI research are working on what they call lack of transparency or interpretability techniques. That's a long word, interpretability, but what that means is starting to figure out a way to understand how the neural net got to a specific decision. And one example of where they're trying to figure this out is with the neural net that identified those 4 materials, right? They have no clue how the AI did that, but they want to try to understand that, and they're trying to create techniques called interpretability techniques that will show them why the AI picked it. And then they give a final example from Case Western Reserve here in the US in New York, where they create a neural net because they're trying to understand what makes it likely that a woman who's had breast cancer, a man who has had prostate cancer would have a recurrence of that, so they can prevent the recurrence. And they created a neural net, and the neural net ended up telling them which people from the scans that they showed the neural net would have a recurrence, and they actually did have a recurrence, which was a breakthrough, but they still had no idea why the neural net said these specific people were going to have a recurrence. And then they developed one of these interpretability techniques that eventually showed them that it was the tissue density on the inside of the breast or prostate. The density of tissue is what causes the cancer recurrence, but they still have no idea why that factor of dense tissue causes the recurrence. So this is in its infancy to learn how AI neural nets figure stuff out, But clearly, as we've talked about in this video and other videos, neural nets are starting to solve problems that human beings can't, because the universe of possibilities is too big, and the neural net can process vast amount of data and get to the answer infinitely quicker than humans can. So neural nets are relatively young, right? Less than 10 years old, the first working neural net, and less than 7 years old from the first quote-unquote perfected neural net, 2015. This is all at the beginning, and understanding neural nets is all at the beginning, and figuring out how they make the decisions they do is all at the beginning. But it's clearly very powerful and leading to breakthroughs that otherwise would have taken months or years or never. So AI, based on the last video I just posted, which was an unannounced live about the warnings about AI from Professor Yuval Noah Harari. This is a very optimistic, positive use of AI. And he says there's plenty of positive uses of AI, and this is one example. Great article from Scientific American, and I will post the link. Thank you. Take care. Bye.